On digital electronics. So we are discussing in the previous classes combinational circuits. We have discussed off adder, full adder, parallel adder, adder circuits, and 2's complement adder subtractor circuit also. And next we have discussed encoders, decoders, multiplexers and demultiplexers, and we have discussed tri-state buffers and magnitude comparators. In this we have followed basically these are all combinational circuits which have some inputs and some outputs, and we identify inputs and outputs, write a truth table, and write the SOP expressions and simplify them. So this is the way of designing the combinational circuits. And in this we discuss sequential circuits in this lesson. So introduction to sequential circuits. So objective of our lesson is the understanding of sequential circuits, types, and the difference between synchronous and asynchronous sequential logic circuits, and the defining the flip-flop. What is the flip-flop, how it will be used, that we will discuss. And the next so what is a combinational circuit? Just for the recap, the circuit whose output depends only on present inputs, that means outputs and inputs are related with that relational expression is the Boolean expression that we have discussed. Output depends on input variables only. And the name of some combinational circuits are decoders, multiplexers, adders, comparators. Are there any logic circuit whose output not only depends on present inputs but also previous output? Yes, those are called sequential logic circuits. The sequential logic circuits is the objective of this lesson. Here in this, observe here, combinational circuit, top diagram is the combinational circuit. It has n number of inputs and it has m number of outputs. That is the combination circuit. That means output depend upon inputs only. Okay, let us see sequential circuit. In the sequential circuit is designed with the help of combinational circuit and additionally memory elements. We take memory elements and with that we store the some of the outputs which are called state of the sequential circuit. That state is provided as a feedback to the inputs. That means the output depends on inputs and previous outputs. That is the idea. So here the output depends upon inputs and previous outputs. These are the previous outputs, these are the present outputs. These present outputs are stored in memory and fed back as input to the combinational circuit. So when the memory outputs are called previous outputs, memory inputs are present outputs. So that you have to remember. And Another important point you have to remember is the clock signal. Here the clock signal. The clock signal is applied to memory element. The clock signal is applied to memory element. That is very important point. That means additionally for the sequential circuit we have found that additional outputs which are called states of the sequential circuits. So these are fed back as inputs and clock is there. The clock is there and memory element. Clock and memory element. These are the additional things to the sequential circuits. So let us consider sequential logic circuit. In this we have inputs and outputs, memory elements, and those are fed back. This is a sequential circuit. So this is the important one. You see the terminology: external inputs, external outputs of the sequential circuit, and some of the outputs are called next state. They are called next state, and they are fed back through memory element to the circuit. So these outputs are called current state, present state. These are the next state. These are the present state. Okay. So these are the internal inputs and internal outputs of the memory element. So this is a sequential logic circuit. And additionally clock is applied, clock to the memory element. So memory element is capable of storing binary information. The information stored in these memory elements at any given time defines the state of sequential circuits. The output in a sequential circuit is a function of not only external inputs but also of the present state of the memory elements. So that means the word sequential means that the things happen in a sequence, one after another, and in sequential logic circuits. The actual clock signal determines when things will happen next. That means the order of events that are to be executed or performed is decided by the clock signal only. So the sequential circuit systematically in sequence manner it does the job with the help of clock event only. The clock signal decides the basic operation at what time and what should be performed. So these are the sequential circuits. So let us see. We know that in sequence circuits changes occur only on the application of a clock signal, making it synchronous. Otherwise, the circuit is asynchronous and it depends upon the external inputs only. Because the sequential circuit performs its job in synchronism with the clock signal. Hence, it is called synchronous circuit. Whenever the clock event is there, then only the circuit will be activated and it does its job. Hence, it is called synchronous sequential circuit. If there is no clock means if it not performs its event of action without clock, then it is called asynchronous circuit. So, to retain their current state, the sequential circuit rely on feedback, and this occurs when a fraction of the output is fed back to the input. So, with the help of memory elements. So now let us consider a simple circuit. Two NOT gates we have taken, two inverters, and the first inverter the second inverter output. The second inverter output is called as Q, and the first inverter output called as Q bar output. Q bar output like this. Then, if the output is fed back like this to the input, this is the input A, the output is fed back like this, then this will act as a memory element. That means it can store the 1 bit information. So there is a small disadvantage in this circuit. This configuration never changes state because the output will always be the same, either 1 or 0. It is permanently set. It is permanently set. So that is the disadvantage of this configuration. That means if A equals to 0, then output is 1, and this is not get output is 0. So A equals 0 means output is 0. Q bar is 1. Q bar is 1. So this is feedback. This 0 is feedback like this. That means the circuit is stuck at 0 only. It cannot changes the state. For example, if the input is 1, then it will be stuck at 1. Q is stuck at 1. So that is the configuration disadvantage. So in the sequential logic circuits, we have synchronous and asynchronous types. Let us compare synchronous, asynchronous. All the flip-flops in this circuit, are triggered at different instant of by time by different clock sources. That means the flip-flops in this circuit are triggered at different instant of time of the clock, different clock sources. So that is the asynchronous. That means clock signal, once clock signal does not activate all the circuits. So that is the asynchronous. And in the synchronous, all the flip-flops are triggered by the same clock pulse at the same time. Only single clock pulse, single clock input signal is used by the overall circuit, and it performs its job. Asynchronous circuits are slow. Synchronous circuits are fast. Next, asynchronous or cumulative propagation delay is the major disadvantage, and in the synchronous, cumulative propagation delay is not present. In the synchronous, instability is more, so less used. Synchronous more stable and widely used. So these are the comparison between synchronous and asynchronous. Let us see the examples of sequential logic circuits. In this, we study flip-flops, resistors, counters, memories. So let us see flip-flops. So it is a bistable multi-vibrator circuit. Any device that has two stable states is called bistable circuit. Flip-flop is a bistable electronic circuit which is used as a 1-bit memory element. It can store 1-bit binary information. So two outputs both must be complementary to each other. So we will find q bar, two outputs available, and the flip-flops can be constructed using either NAND gates or NOR gates. So RS flip-flop is there. So let us consider NAND latch is shown. So the RS latch is formed with two cross-coupled NAND gates or NOR gates only. So universal gates, generally NAND and NOR gates are the universal gates which are used to design the flip-flops and the latches. So let us consider first begin with the latch. After latch we will discuss flip-flop. So here latch is a bistable circuit that can reside in either of two stable states by virtue of feedback. That is the advantage of the latch. So we have two types of latches available to us. One is a NAND latch, another one is the NOR latch. So NAND latch is the one which is constructed like this. Here the output is fed back to the input of down NAND gate. Output of this NAND gate is fed back as input to this NAND gate like this. This is very very important. So this input is called OR, this input is called S, and you have the output Q and Q bar, complementary outputs. This is called complementary outputs. So this is the truth table of the NAND latch. Let us briefly analyze it. Because or yes, four combinations 0 0, 0 1, 1 0, 1 1. Total four combinations let us take, and each combinations let us study. Now let us consider 0 0. First combination 0 0. When 0 0 applied, outputs are 1 1 1 1, but we don't accept this output combination because outputs must be complementary. That is very important point. That means if q bar This is q means this is q bar, that's all. That means q equals to 1 means this must be 0. Q bar must be 0. If q equals to 0, q bar must be 1. That means outputs must be always complementary to each other. This is the condition. But this condition is not satisfied with r equal 0, s equal 0 inputs. R equal 0, s equal 0 inputs are not following the desired outputs. Hence, this state is called unpredictable state. This is called unpredictable and prohibited state combination. Undefined. It is called undefined. That you have to remember. Next, let us see 0, 1. 0, 1. Whenever one NAND gate input is 0, if this input, other input is not known, question mark, another input is not known, one input is 0, though other input is unknown, we can easily say the output of NAND gate. It produces the output because one of the input is 0 means NAND gate output always 1. This is clear, though this second input is unknown. That is the important point you have to keep in mind. Okay, now this one output is fed back to here 1. That means the down NAND gate is having two inputs 1, 1. When the NAND gate inputs are 1, 1, the output is 0. The output is 0. That means whenever r equals to 0, s equals to 1, q equals to 1. Q equals to 1. You have to keep in mind this combination. R equals to 0, s equals to 1 makes the latch output to 1. That means it is setting the latch to 1. It is setting the latch to 1. That means latch is set to 1. Let us consider 1 0 combination. 1 0 combination. For 1 0 combination, observe here, the top NAND gate is having r equals to 1. Other input is not known. Other input is not known. Hence, you cannot determine the output of the NAND gate, because output of NAND gate can be determined whenever both of or all of the inputs are known, because one of the input is 1 means other input also must be known, then only we can say its output. But if you see the down NAND gate, if you observe the down NAND gate, the down NAND gate is s equals to 0. S equals to 0. So s equals to 0 means another input is not known. Another input is not known here. But though another input is not known, you can easily determine the output of this down NAND gate because one of the input is 0. So output is 1. Output is 1. Now this output 1 is fed back to here Now it is 1. Now both the inputs are 1 1. It is known. The top NAND gate, both the inputs are known now. Hence, the output can be determined. What is the output? 1 1 means input output is 0. That means whenever this combination is there, 1 0 combination, then the output Q equals to 0. The output Q equals to 0. That is reset. We can call it as reset. The latch state is reset. Okay. Now let us consider last combination 1 0. 1 0 combination. This is very important combination. You have to understand it clearly. So this is 1, this is 1. Then what happens is other other input must be known, because here you don't know the input, here is also you don't know the inputs. Both are unknown. So you cannot say the outputs. You cannot say the outputs. That is the problem here. That is the problem here. But you remember that, for example, let us assume the latch is in the state of 0. Let us assume Q equals to 0, Q bar equals to 1. Let us assume this. Why? We are assuming that the latch was in the previous state. The previous state was 0, that is the reset state. Let us assume. In this, if you observe, this 0 is fed back here and this 1 is fed back here. Then what is the top NAND gate output? 1 1. Output is 0. Down NAND gate 0 1. Output is 1. That means the assumed output states are not changing. The assumed outputs are not changing when you apply 1 1. When you apply 1 1. Hence, that means whenever you apply 1 1 as inputs, the latch assumes its previous state only. That means no change. Hence, this is called memory combination. Memory. That means the latch is acting as a memory element. It is acting as a memory element. That is the important thing you have to remember. Now, let us consider the same combination 1 1 and assume the output. Previously we assumed a 0 out state. Now let us assume 1 state. That means set. The latch was set. Previously the latch was already set. That means Q equals to 1. That means Q bar is 0. This is assumed. This is the assumed state is 1 set. Now let us apply 1 1 now. R equals to 1, S equals to 1. Okay. Then this Q equals to 1 is fed back here, that is 1. This 0 is fed back here, that is 0. So what happens? For 1 0, the output is 1 only. For 1 1, the output is 0 only. There is no change. There is no change in the output. The assumed output does not change. That means the previous output does not change whenever you apply 1 1. Whenever you apply 1 1. So that is the. So hence it is called no change state or previously state is stored in the latch. Previous state is stored. Previous state is memorized by the latch. Memorized. So this is the important thing that you have to remember. So this is the SR latch with NAND gates. So this is the explanation. Already I have in detail. For R equals 0, S equals to 1, the flip flop, the latch will set to 1. When R equals to 1, S equals 0, the flip flop is reset. The flip flop is reset. For 1 1, the flip flop, the latch will act as memory element. So let us consider another latch, NOR latch. So NOR latch, if you consider NOR latch, let us take the first combination 0 0. Let us take the first combination 0 0. That means whenever you take the combination 0 0, you cannot determine the output of NOR gate because another input also must be known, but another input is not known. In both the NAND gates, top and bottom NOR gates, in both the top and bottom NOR gates, you don't know the inputs. Only one of the inputs known, that's all. Hence, you cannot determine the outputs of the NOR gate. This is the problem. Hence, let us assume outputs. Let us assume outputs. So, for 0 0 input combination, let us assume the output is 1. Q equals to 1. Then Q bar is automatically it is 0 because complementary output. Okay. We assumed 1 0. Now let us analyze. So this 1 is feedback to this NOR gate and this 0 is feedback to this NOR gate. Okay. So this is the thing. Now here 1 is there, here 0 is there. So now if you observe both the inputs are known, hence 0 0 means output is 1 only. Here down NOR gate 1 0, output is 0 only. So that means the assumed output is not changing whenever you apply 0 0 as inputs. R equals 0, S equals 0. So that means no change. That means the NOR latch acting as a memory. It is storing the previous state. Assumed state means assumed outputs means previous outputs. Previous outputs. Those are all previous outputs. Now that is a important combination in this. That is no change means the flip flop the latch will act as a memory element. Now let us consider 0 1 combination. That means R equals to 0, S equals to 1. Observe here For this NOR gate, you can't tell the output because other input is unknown, means you cannot tell the output. But in the down NOR gate, you can easily tell the output. Why? Because one of the inputs is 1. So whenever one of the input is 1 means 1 plus anything is 1 only. 1 bar, it is 0. That means this NOR gate output is 0. This 0 is fed back here. Now it is 0. 0 0. Output is 1. Output is 1. So that means whenever R equals to 0, S equals to 1, Q equals to 1. That means set. The latch is set to 1 because S equals to 1. The latch is set to 1. Now let us consider 1 0. R is 1, S is 0. In this case also, the top NAND gate, the top NOR gate output you can easily determine because one of the inputs is 1. So this is output is 0. So the down NAND gate, the down NOR gate output you cannot determine, but feedback, if you take the feedback 0, 0 0 means output is 1. Now it is clear. That means whenever R equals to 1, S equals to 0, the latch will reset to 0. It is reset to 0. That is the understanding. Next, let us consider 1 1. 1 1 combination. Whenever 1 1, what happens? You can easily determine the outputs 0 0. But this is prohibited. The outputs should not be equal, same, because outputs always must be complementary. That is the condition. Hence, it is called unpredictable state, prohibited state, undefined state of NOR latch. In the NAND latch, 0 0 was prohibited and undefined. But in the NOR latch, 1 1 is prohibited and undefined state. So let us take the flip-flops. Flip-flop is a 1-bit memory element. It is a 1-bit memory element. So we are going to study different kinds of flip-flops. They are SR flip-flop. S means set, R means reset, hence SR flip-flop. And JK flip-flop. J means set, K means reset, JK flip-flop. And D flip-flop, that is delay flip-flop. And T flip-flop is toggle flip-flop, toggle flip-flop. Another important concept we have to discuss is the necessity of the clock. The clock plays important role in sequencing the operations of sequential circuits. So in a sequential system, there may be several things going on at the same time. So we need some timings or clocking mechanism so as to decide when the output is going to change. That is, at which point of time things will change. So that is the important clock functionality. There are several stages in a circuit, and each of these stages will have to take an input from previous state, process it, and gives output. That means for every stage it takes the input from the previous circuit, and it takes the previous state condition and process it, and finally it produces the output. That is the necessity of the clock. They cannot work at random. You see, the sequential circuit cannot work at random. It should work systematically. If they work randomly, some of them will work faster than the other, or some of them will take the previous output of the previous state and process it even before the present output is processed. So we try to synchronize the working of all the subsystems in a sequential system by using a clock. Therefore, clock is used to bring some regularity in the sequential system. So, this is the important role of the clock signal. So, a clock signal is a particular type of signal that oscillates between a high and a low state, and it is used to coordinate actions of digital circuits. So there are different types of triggering of digital circuits. What is triggering? Triggering is activating the circuit. That is called triggering. So the clock always decides the functionality of the circuit. Hence, there are different types of triggering mechanisms used. So here the flip-flops are synchronized bistable devices. The output changes the state only at a specified point on a triggering input called the clock. Thus, in a synchronous flip-flop, for change of state, an external synchronous clock pulse is necessary. That means the flip-flop or latch must be synchronized with the clock and activated with the clock only. Okay. So here let us consider edge triggering. So there are two types of edge triggering techniques, mechanisms used. Here, edge triggering means that the flip-flop is changing the state either at the positive edge, rising edge, or at the negative edge or falling edge of the clock pulse. That means, you see, this is rising edge, positive edge. These are all positive edges. That means the clock is changing from 0 to 1. Here also positive edge, positive edge, positive. These are all positive edges. Whenever the circuit is, the flip-flop is activated at these positive edges, then that flip-flop is called positive edge triggering flip-flop. Positive edge triggering flip-flop. Its symbol is this. You see, the positive edge clock is like this. If you observe, there is a clock input like this. So this is the positive edge. If you observe, this is the positive edge. Positive edge clock. And next edge triggering is the negative edge triggering. These are negative edges. That means 1 to 0 changing. Negative edge. This is also negative edge, negative edge, negative edge, negative edge, like this. These are negative edges. When the flip-flop or digital circuit is activated at the negative edge, then it is called the flip-flop or digital circuit is triggered at negative edge triggering type. So this is called negative edge triggering. If you observe here, a bubble is there and arrow mark is there, both are there, but here is only arrow mark, here bubble and arrow mark, like this, negative edge triggering. Here arrow mark and bubble also. This is the clock input, clock. This is negative edge triggering flip-flop. Next, level triggering. In the level triggering, edges are not taken into consideration, but level of the clock will activate the circuit. So the flip-flop respond to low or high level of the clock signal. The simplest way of controlling the flip-flop is only through level triggering clock. So this is high level, positive level, that means high level. Level means you see the clock signal, you understand. This is the clock. This is the positive level because it is 1. This is the negative level, 0. So positive level means this, positive level. These are positive levels. Negative level means this, negative level. This is also negative level. Two types. Okay. So low level, this is the high level triggering. This is level triggering combinations. This is the high level, this is the low level. For the low level, you see only bubble. If you observe, because there are no arrow marks here, no arrow marks in both the cases, that means they are not edge triggering, they are level triggering only. Bubble indicates low level, no bubble means high level. That is a symbolic representation you have to remember. So we are going to discuss these flip-flops in the next classes, and with this we have discussed sequential introduction to the sequential logic circuits and types of sequential logic circuits. We have discussed NAND NOR latches and compared types of asynchronous and synchronous sequential circuits comparison, and edge triggering, level triggering circuits also we have discussed. The output of sequential logic circuit depends on present inputs, previous outputs, A and B. A and B. And in RS NAND latch, R equals 0, S equals to 1 means the output is 1. Okay. The unpredictable state occurs in NOR latch when 1 1. So these are the questions, possible questions you have. So with this, we conclude our lesson. Thank you.